8.5 Multiplication involving indices. Learning intentions. Understand how to multiply numbers and algebraic expressions involving indices. Recognize and apply the rule for multiplying powers with the same base. Develop fluency in simplifying expressions using index laws. Success criteria. I can multiply powers with the same base by adding the indices. I can simplify numerical expressions involving indices correctly. I can simplify algebraic expressions using index laws. I can show clear working out when applying index rules. Multiplying indices worked examples. When multiplying powers with the same base, we add the indices. Example 1. 2 to the power 2 times 2 to the power 1. We have the same base, so the big number at the bottom is the same, it's a 2. So we can just add the powers. So we get 2 to the power of 2 plus 1, which is 2 to the power of 3. And that gives us 8, because 2 by 2 by 2 is 8. Next one, 3 to the power 1 times 3 to the power 2. Multiplying powers with the same base, we add the powers. So that gives us 3 to the power of 1 plus 2, which is 3 to the power of 3, which is 27, because 3 by 3 by 3 is 27. Example 3. 5 to the power 2, or 5 squared, times 5 to the power 2. Multiplying powers with the same base, we add the powers. So that gives us 5 to the power 2 plus 2, which is 5 to the power of 4. Which is 625. So 5 by 5 by 5 by 5 is 625. 4 to the power 3 times 4 to the power 2. Multiplying powers with the same base, we add the powers. 4 to the power 3 plus 2, which is 4 to the power 5. And then 10 to the power 2 times 10 to the power 3. Multiplying powers with the same base, we add the powers. So we get 10 to the power of 2 plus 3, which is 10 to the power of 5. When multiplying powers with the same base, we add the indices. So here are some examples with letters. So x to the power 2 times x to the power 3. Multiplying powers with the same base, we add the powers. So we get x to the power of 2 plus 3, which is x to the power of 5. A to the power 4 times a to the power 1. Multiplying powers with the same base, we add the powers. So we get a to the power 4 plus 1, which is a to the power 5. Y to the power 3 times y to the power 2. Multiplying powers with the same base, we add the powers. So we get y to the power of 3 plus 2, which is y to the power of 5. So here we have some examples with numbers and letters. So remember, when multiplying powers with the same base, we add the indices, or we add the powers. So 2x squared times x cubed. So we are multiplying powers with the same base, so we'll add the powers, but we also have a big number in front. And x cubed is technically 1x cubed. So we're going to multiply the big numbers. So 2 times 1 will just give us 2. So we still have 2x. And then we're going to add the powers. 2 plus 3 gives us 5. So we get 2x to the power of 5. In the next example, we are multiplying powers with the same base. So we're going to multiply the big numbers. 3 times 2 will give us 6. And then we're going to add up the powers. So it's going to be 6a to the power of 2 plus 3, which gives us 6a to the power of 5. So we multiply the big numbers and add the powers if the bases are the same. Next, 5y times y to the power of 4. So that's technically 1y to the power of 4. So 5 times 1 is just 5. And then y on its own is really y to the power of 1. So it's going to be 1 plus 4, which is 5. So we get 5y to the power of 5. You will have already learned that 5 times 5 can be written as 5 squared, or 5 to the power 2. Similarly, a times a can be written as a squared. A times a times a can be written as a cubed. In the term a squared, the little 2 at the top, is called the power, or the index. Now, a squared times a squared is going to be a by a by a by a, which is a to the power of 4. A squared times a cubed is a by a by a by a by a. And a by a by a by a by a gives us a to the power of 5. So again, when multiplying the same number to two powers, we add the indices. So that's another way of saying multiplying powers with the same base, we add the powers. To multiply 2x by 3x, we first multiply the big numbers, 2 by 3, and then we multiply the x by x. So 2x by 3x is 2 by 3 by x, which gives us 6x squared, because 2 by 3 is 6, and x by x is x squared, because x is really x to the power of 1, And the other x is really x to the power of 1, and 1 plus 1 makes 2. Similarly, 3a times 4b, we're going to multiply the big numbers, so 3 times 4 will give us 12. But then we're not going to have any powers because we have a times b, so the letters are different. So we're not going to have ab squared, it will just be ab. Because a letter times a letter, we stick them together. Simplify. 3 bracket x squared minus 2. So we're going to do 3 times x squared is 3x squared. A number times a letter, we stick them together. And 3 by minus 2 is minus 6. Then we have minus 3x by x. Now x on its own is really to the power of 1. And x on its own is really to the power of 1. So we're going to have minus 3x to the power of 1 plus 1, which is minus 3x squared. Because 1 plus 1 makes 2. And then minus 3x by 5 is minus 15x. A number times a letter, we stick them together. Now minus 3a multiplied by a minus 7. Those a's are really to the power of 1. So minus 3a to the power of 1 times a to the power of 1 is going to be minus 3a squared, because 1 plus 1 makes 2. And then minus 3a times minus 7, and minus by minus gives a plus. 3 by 7 is 21, and we just stick on the a. Example 2. Remove the brackets and simplify each of these. So those x's are really to the power of 1. So 2x by x is 2x squared, because 1 plus 1 makes 2. And then 2x multiplied by 4 is plus 8x. Then 5x multiplied by 2x. So those x's are really to the power of 1. So 5 by 2 gives us 10, and x by x is x squared. And then 5x by 1 is minus 5x. Then 2x squared plus 10x squared gives us 12x squared, because we simplify. So we can add or subtract like terms, and they are like terms because they have the same letter and the same power. And then 8x minus 5x is minus 3x. So remember, when we're adding or subtracting like terms, the powers never change. Remove the brackets and simplify each of these. So those x's are really to the power of 1. So x by x is x squared. And then x by y, a letter times a letter, we stick them together. We just get xy, so no powers. Now the 3x times the 4x, those x's are really to the power of 1. So 3x by 4x, we multiply the big numbers. 3 by 4 is 12. And x by x is x squared, because 1 plus 1 is 2. And then 3x by minus 3y, well, a plus by a minus is a minus, and 3 by 3 is 9, and then we just stick on the xy, so there's no powers here, because the letters are different. And then plus 2xy, we just bring that down. Now we simplify. So x squared is really 1x squared, so we're going to circle the like terms. So 1x squared plus 12x squared is 13x squared. So we're adding or subtracting the like terms now in this step, and the powers do not change. And then 1xy minus 9xy plus 2xy gives us minus 6xy. So again, the powers don't change at this stage. When we're adding and subtracting like terms, the powers do not change. They only change when we're multiplying. So 1 minus 9 is minus 8, and minus 8 plus 2 is minus 6, and we just stick on the xy. Example 3. Find the value of 2x squared minus 6x plus 7 when x is equal to 3. So we write out our expression. We replace the letters with brackets. And into the brackets, we're putting 3. And then 2 times 3 squared is going to be 2 times 9. Minus 6 times 3 is minus 18. And we bring down the plus 7. 2 times 9 is 18. Bring down the minus 18 and the plus 7. 18 take away 18 will cancel, and we're left with 7.